Hi guys, and welcome to the video for the real number system and its properties. So this is the beginning of Algebra 2, so we're going to start by covering the real number system and its properties. We're doing this because the real number system is the basis for algebra, and in order to actually understand algebra, we must know the properties of the real number system. And we will know that we are successful when we can simplify basic expressions using the properties of the real number system. So let's get started. The first thing that we're going to cover is what are real numbers. And you could pause the video here if you'd like to take these notes down, but I'm going to kind of go through them a little quicker. A real number is a value that represents a quantity along a continuous number line. So real numbers can be ordered, which means they're put in order from least to greatest. And the symbol for the set of real numbers is a script R. The symbol that I have here on the screen here, which is the letter R in the typeface blackboard bold, but that's more for if you're typing on a computer. The real numbers include things like the counting numbers, the natural numbers, and that uses a symbol N. The whole numbers, which don't really have a symbol. The integers, which uses a Z to indicate that that's that set of numbers. The rational numbers, Q, so numbers like -0.5 and 6.25, or irrational numbers, pi, -3.24, 234, 234, etc., etc. So what is the difference between these specific sets of numbers here? The counting numbers are the numbers that you learned to count with as a young kid. Okay? So those are the numbers that you kind of learned how to count with as a young kid. Whole numbers are over here, and the whole numbers are non-decimal positive numbers. Integers are the same thing but a little bit less restrictive. Integers, so I'm trying to get my pen up here. Integers are non-decimal numbers, so it's any of the non-decimals. It can be positive or negative. Rational numbers are any number that can be represented by a fraction. And irrational numbers, the last number of the bunch, are numbers that cannot be represented by fractions. So that's what real numbers are and those other subsets of numbers. So let's continue on. The way to look at the real number set is all of the other sets of those numbers, the natural numbers, whole numbers, integers, rational numbers, and irrational numbers, exist within the real number system. So this means that integers are rational numbers that are also real numbers. The only set of numbers that exist outside of this sphere is the set of imaginary numbers, which we will not study till later this year. So outside of this big sphere, there are imaginary numbers. Imaginary numbers. However, properties work from the inside out, going back into the real number sphere. All the properties of natural numbers apply to whole numbers, and all the whole number properties apply to integers. All the integer properties apply to rational numbers, and all of those apply to real numbers. So when we talk about the different types of numbers, if a number is a natural number, that means it is a whole number. It also means that that number is an integer, a rational, and a real number. So that's what I mean with these arrows. If it is a whole number, it means it's also an integer, a rational, and a real. So the more you get in, the more specific the type of number you are dealing with. Another way to visualize the real numbers is being a continuous number line. So here I drew an imaginary number line, and I'm visualizing it. Every number that we can think of exists on this number line. It actually exists. Like, it can be quantified and represented in some sort of way on this number line. So -4 is an integer. 0 is an integer. 4.5 would be a rational number, but they are all here and actually exist on this number line. 4.5 would be right about here-ish. Numbers like 2 and 3 are real numbers that can be classified into more specific categories like integers and whole numbers and counting numbers as well. So just keep that in mind as we move forward here. Okay, so here's a table that has an overview of the properties of all real numbers. When we perform operations on real numbers, certain laws and properties hold that govern the answers we get. We understand these sorts of things to always be true. So these are like laws of mathematics, and they're always true, no matter what. If you're working with real numbers, and we will be all year, these things are always true. So you have properties for addition and multiplication. When we talk about, I'm going to go through each and every one of them and give you examples of what they look like numerically. When we talk about them, just remember that there is an addition version and a multiplication version. To save space, I have put them on the same pages. So you can write those down as we go through them. The first one is the commutative property. The commutative property states that in addition and multiplication specifically, so it doesn't work for subtraction, it doesn't work for division, the order in which you write the operations does not matter. So you can commute them back and forth. The expression gives you the same result backwards and forwards. And the examples I gave are 3 plus 2 is 5 over here, and that's equivalent to the other side, 2 plus 3, which is also 5. So it doesn't matter what order I write that in, it still gives me the same result. On the multiplication side, I get 16 and 16 again. So I have I have proof that these properties hold. The next property is called the associative property. So I kind of get confused on this one, so I like to think about I reassociate, meaning regroup the elements together, and you still get the same result from the expression. So take a look. If I'm adding, okay, I have 3 plus 2 plus 4, but the 2 plus 4 is in parentheses, and we know from order of operations that 2 plus 4 would be 6. So the expression would simplify to 3 plus 6, which is 9. And on the other side, 3 plus 2 is 5, plus 4 gives me 9 as well. So it holds for addition. And if you do it on the multiplication side, I have 8, and then times 2 times 3, which I would do that first because it's in parentheses, so that would give me 6, equals, over here it would be 16 times 3. I get 48 for this answer, and I get 48 for this answer, so the property holds. We're going to move on to the next one, which is the identity property. This property is considered trivial, meaning that you probably already understand this to be true. It seems obvious, but we're still going to state it because it is important to remember. In addition, adding 0 preserves the value of the input, and in multiplication, multiplying by 1 preserves the value of the input. So what that fancy phrase means, preserves the value of the input, is that if I add 0 to a value that I already have, I did not change the value. Or if I multiply by 1, or, and I'm going to make this exception. So if I multiply by 1 or something equivalent to 1, then that preserves the value of the original input. And that's important to remember. We're definitely going to need those skills later on this year. And the one that we're definitely going to need almost right away is the inverse property. in a real number system, when you add the opposite value of a real number, you will get 0. If you multiply by the reciprocal, which means 1 divided by the number, you will get 1. And these are important because we use the addition inverse property to cancel things. So you can see 8 plus negative 8 equals 0. That's how we move values from side to side in equations. And for the multiplication, we use this to reduce coefficients in equations. So if I have 4x, I would multiply it by 1/4. That's the equivalent of dividing by 4, and I would get 1 as a coefficient. Well, that happens because the multiplication inverse property is always true. So 4 times 1/4 equals 1. And the last property is the distributive property. So the distributive property says that multiplying a number by a group of numbers added together is the same as doing each multiplication separately. So 3 times the quantity 4 plus 5 is equal to 3 times 4 plus 3 times 5. And I'm going to actually do them differently to show you this. 3 times, you do the parentheses, 4 plus 5 is 9. And then over here, I'm going to get 3 times 4 is 12, plus 3 times 5 is 15. So I get 27 on this side, and I get 27 on the other side. So I get the same answer no matter how I do it. The distributive property is useful, though, when we are simplifying variable expressions that may not add together like 4 plus 5. If we have something like x plus 5, we're going to want to simplify that expression by using the distributive property. And so I'm just going to give you a few quick examples. So which real number system property is illustrated below? You're going to identify the property, and you're going to say if it is the addition or multiplication version. So I see, for number 1, 4 plus 3, in parentheses, plus 1. And on the other side of the equation, I see 4, the same numbers, but then the 3 and the 1 are grouped together in parentheses. So I have regrouped them, and grouping is like association, so I know that this one is the associative property, and I'm actually going to type it rather than write it. This one is the associative property, and I notice that it's using plus signs, so it's the associative property of addition. Number 2, I see that I have x times y plus 0 equals x times y. So I had a value, I added 0 to it, and I ended up with the value. That is the identity property. And because we added 0, that would be of addition again. So we have the identity property of addition. And the last one, 8 times 1 equals 8. So I multiplied 8 by 1, so I definitely know that it's going to be of multiplication. But I multiplied 1, or 8 times 1, which happens in the identity property. So this is the identity property of multiplication. So that's the type of problems that we're going to deal with for the real number system here. And that's it, guys. Today, we learned that real numbers exist in a set. They encompass every number that you can think of except for imaginary numbers. There's 5 main properties for both addition and multiplication for a grand total of 10. And then we should be able to identify which property is illustrated in an expression or an equation. So that's it, guys. Thanks for watching, and I will see you in the next video.